Hello, Algebra 1. Today we are starting our new unit, which is all about graphing quadratic equations. So quadratics are something we worked with in our last unit with factoring, and today we are really going to start graphing these and seeing what they look like. So the graph of a quadratic equation is called a parabola. And we are going to go ahead and fill in this table to see what a parabola looks like. So I have this table set up with my x values, and then this is my equation of what I call the parent function, just y equals x squared. And I'm going to go ahead and just plug these numbers in for x. I'm going to fill in this part of the table first. And then I'm going to evaluate and plot the points. All right, so -2 squared, if you use your calculator, make sure that you have the -2 in parentheses. And when you square it, you get 4. -1 squared is 1. 0 squared is just 0. 1 squared is 1 again. 2 squared is 4. And 3 squared is 9. And now we're going to go ahead and we are going to plot these points. So I have -2, 4. I have -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. All right, now this is called a parabola, and we have something called the axis of symmetry. It's the line that cuts the parabola in half to form a mirror image. So we're going to draw that axis of symmetry. It's actually right here along the y-axis. Oops. And our axis of symmetry for this type of parabola is always going to be a vertical line. And because it's a vertical line, it's going to have the equation of x equals. And we can see that we're at the number 0. Okay, now using the axis of symmetry, we can actually go ahead and plot another point because we're always going to be the same distance on each side. So if you look, the point that we're missing is actually -3, 9. That kind of completes our image, and then you can go ahead and sketch it. And if you also notice, all of our y values here are positive. Think about why that would be happening. Well, what we have found is that when we square any number, it always becomes positive. All right, so this is just our standard parabola. We're going to call this the parent function. We'll come back to this in a little bit. For right now, though, we're going to talk about something called critical points. Critical points are the different parts of a parabola. All right, so we have 3 main types of critical points. The first is called a 0. This is where the parabola crosses the x-axis, and these are also called x-intercepts. Okay, so they are the same thing. So this guy would be considered a 0 or an x-intercept, and so is this one. And a parabola can have either 2, 1, or 0 zeros. Okay, so we'll look at what that looks like in just a moment. We also have something called the vertex. A vertex, in the past, we thought of the vertex as the corner. You can still kind of think of that as you want. It's like the turning point of our parabola, and it either is a minimum or a maximum. So when a parabola has a minimum, this is the lowest point on the graph. And when the parabola has a maximum, this would be the highest point of the graph. Okay, and then finally, every parabola also has a y-intercept, which is where the graph crosses the y-axis. Okay, and this is something that we've seen with linear relationships as well. So this guy right here would be your y-intercept. All right, so those are your critical points. Now we're going to work to identify them from actual graphs. Okay, so what I have here is this blue line that you can see. This is your x-axis, just to make that more clear. So when we're looking for how many zeros a parabola has, we're looking for how many times we are hitting that x-axis. So in this situation, we have 2 of them. In this situation, we only have 1. And then this would be an example of not having any zeros. because you can see we do not hit that x-axis at all. Okay. All right, so let's practice. Does this parabola have a minimum or a maximum? And we're not looking for a yes or no here. We're looking for which one of those is it. So we have a highest point here, so this is going to be a maximum. When we're being asked what are the coordinates of the vertex, that's asking us for where this point actually is. Okay, remember when you do points, your x comes first, so this is going to be 2, 8. How many zeros does the graph have? That's like what we were just doing above. Here's your x-axis down here. We have 2 of them. And now we're going to go ahead and give the coordinates of those zeros. So it's hard to read that, but that looks like a 6, 0. And then we also have, this is a -2, I believe, 0. All right, and then finally, coordinates of the y-intercept. That's where we're hitting the y-axis. That's going to be this guy, and that's 2, 4, 6. Make sure you have 0, 6, not 6, 0. Okay. All right, let's try another one. This graph has a lowest point, so that would be a minimum, not a maximum. And again, the vertex is just asking you for where that minimum is. All right, so let's see. This looks like it's about a 1, 1, 2, 3, 4, 5, 6, 7, 8. I think this is down at -9. Oops, I put that in the wrong spot. I meant to do that. There we go. All right, how many zeros does this graph have? Well, here's my x-axis. I've got 2 of them. Okay. All right, and now the coordinates of those. 1, 2, 3, 4. So I'm at 4, 0. And this is 1, 2. Make sure you have your negative, -2, 0. And then finally, y-intercept, that's where I hit right down here. I believe that's going to be a -8 because that guy was -9. Make sure you have your 0, comma. All right, great job. Let's move on. Let's talk about axis of symmetry more. So now that we know some vocab about parabolas, let's talk more about the axis of symmetry. The axis of symmetry, or we may call it the AOS, always goes through the vertex, which again is your min or your max of the parabola. And since our axis of symmetry is always a vertical line, it's always going to begin with x equals. All right, so let's take a look at number 4. We're going to identify the vertex for both of these graphs and then to determine the equation of the axis of symmetry. That was a struggle. All right, so this vertex, it looks like we're at 3, 2. Your axis of symmetry would be this line right here. It is vertical, so x equals. And again, it's always going to go through that x coordinate of the vertex. Okay, we'll try this again. This blue line is your x-axis, just to make sure you see where you're at. Okay, so here's my vertex. This is at -1, -4. And if you want to draw that axis of symmetry, you can. Again, it's vertical, so it's x equals, and we're going through -1. All right, so again, these values will always match, all right? The axis of symmetry is always going through the x coordinate of your vertex. All right, let's try some extension problems to this. So we have this grid off to the side that you can use if you want to get some help. So we have an axis of symmetry at x equals 0. That's this guy right here. And you have a point at 5, 3. So what we're looking for is where the symmetrical point would be on the other side. Okay, so take a look. See how you are 5 units from the axis of symmetry? That means you're going to be 5 units from it on the other side, which is just going to be at -5, 3. Notice that the y coordinate is staying the same. It's just the x coordinate that's changing. All right, so let's try this again with a different axis of symmetry. Axis of symmetry at x equals 2. Okay, so this is where the symmetry happens, and we are at 8, 0. Okay, so again, count your distance to your axis of symmetry. So 2 to 8, that is 6 units. So now I'm going to go 6 units more. 1, 2, 3, 4, 5, 6. All right, and that yellow line should be right in the middle, and the name of that point is -4, 0. Okay, let's try again. X equals -4. Here's my axis of symmetry. -9, 3 is up here. Count your distance from -9 to -4. That is 5 units. So we're going to go 5 more units. 1, 2, 3, 4, 5. And that's going to be at 1, 3. All right, so now we have 2 examples where these numbers do not fit on our graph. All right, so let's think about how we would do this. I have just a little picture right down here. My axis of symmetry is at 150. I'm going to go ahead and put a 150 right here. And my first point is at 100, 6. Well, 100 comes before 150, so I'm going to put that right there. All right, so take a look at the distance here. How far apart are they? They're 50 apart. Okay, so you need to go 50 more. 150 plus 50 gives us 200. It's only your x coordinate that's changing. Your y coordinate is going to stay exactly the same. All right, let's try one more like that. -20, put your axis of symmetry right in the middle. -23, that is smaller, so that's going to go on the left side. Figure out the distance between these two. It is 3. So you're going to go 3 more on the other side. -20 plus 3 is -17. All right, and again, the y coordinate is going to stay the same. All right, great job. The last thing we're going to do is talk more about the parent function, which I already mentioned this at the beginning of our lesson, but now we're going to look at some transformations. Okay, so a lot of times our parabolas are shifted, and we are going to use Desmos to see how these parabolas are different from the parent function. Okay, so I'm going to go ahead and pull Desmos up here. I'm going to make it a little smaller. Let's see if this works. Okay, and I'm going to type in the first one. So I have y equals x squared plus 5. And if you notice, this parabola has shifted up from the parent function. In fact, I'll just leave the parent function here so we can see the original. There we go. All right, so our blue one is the original. Move that in front. Okay, and we can see clearly that it has shifted up 5. Okay. All right, let's try again. X squared minus 2. Okay, so again, the blue is the original. X squared minus 2 is the red one. And what do you notice about this one? From the parent function, it has shifted down 2. Okay, and again, you might notice kind of a common theme here. All right, so think about what's going to happen with this one, x plus 7 squared. X plus 7 squared. Oops, helps if I type correctly. This one I'm going to zoom out a little bit. It may not be what you expected. In this situation, we have actually moved, here's 7, we have moved to the left 7. Okay, this moved us to the left 7. All right, let's see what this one does. X minus 3 squared. Oops. Ah, interesting. Again, blue is your original. Red moved us to the right 3. All right, so now let's try putting a negative in front. Maybe you have an idea of what that does. It, in fact, reflects our parabola over the x-axis. Okay, or you can say it flips it over. All right, let's try another one. 5x squared. I'll get rid of that negative and I'll put a 5. Okay, again, blue is your original. Take a look at red. It didn't move it either way, but it did make it skinnier. Okay, or we could say more narrow. All right, 2 more to try. We have negative 1/3 x squared. And this actually does 2 things. Take a look. If I take out the negative, you should notice that the red is much wider. Okay, it didn't move it, but it is wider. And when I put the negative, it also is going to flip it over. So it's wide and reflected. In number 13, I also have 2 things going on. I have x minus 2 squared. Get rid of all this. Okay, so there's the x minus 2 squared. All right, notice it moved it right 2, but I'm also adding 8. So think about what that did. It not only moved it to the right 2, but we also moved up 8. All right, so see if you can predict what this one is going to look like. Negative x plus 1 squared minus 3. It's actually 3 things that's going to happen. Okay, go ahead and pause the video for a second and see if you can write down what your thoughts are. And then I'm going to type this in. All right, welcome back. Let's look at what happened. So we have a minus here. That means our parabola did get flipped over. The plus 1 means it moved to the left 1. And the minus 3 moved it down 3. So it actually did all 3 things. Okay, it reflected over the x-axis. It moved left 1 and down 3. All right, so we're going to talk a lot more about this tomorrow, but let's see if we can summarize our transformations here. When it was x plus a squared in the parentheses, it actually did the opposite of what we expected. See this plus? It actually moves it left a units. X minus a squared, okay, so like number 9, this moved it right a units. When we were adding a number on the outside, it kind of did what we expected. It moved it up a units. And when you have the minus, it moves it down a units. And finally, when we have a negative in front, this reflects our graph over the x-axis. So these are all things we're going to talk about more tomorrow. But again, you can do these all yourself on Desmos as well. All right, have a great day. Bye.